Hi guys, welcome to the next video towards learning OpenCV. In this video, we are going to see how to identify a car number plate using OpenCV and extract the text from it. First, I'm going to import all the important packages. So let me import them. I'm going to import numpy np, import cv2. This is for importing our OpenCV. Import matplot .pyplot as plt, and I'm going to make it as matplotlib inline for this, and I'm going to import other two packages. Let me run this one first. Okay, all the packages has been imported. I'm going to use this piece of image for my identification. This is the image I'm going to use for my testing purpose. So let me read the image. So I'm going to read img equal to cv2 dot read, sorry, cv2 dot imread image1 dot jpg. So I'm gonna read this image. After that, I'm gonna convert this into a grayscale image. So cv2 dot pt color. I'm gonna use the image which I read in the previous step, and I'm gonna give color pgr2 gray. So I'm gonna convert the pgr to gray, and I'm gonna show the same using matplotlib. So I'm gonna give plt dot imshow. I'm gonna show the grayscale image, so I'm gonna give this gray over there, and I'm gonna show it as cv2.bgr, which is cv2.color underscore bgr, which is blue, green, red, and I'm gonna convert into RGB, and let me see whether it is working fine. Yeah, I'm able to read the image, and I'm showing the same as a grayscale image. Now let's try to remove some noise over there. So I'm gonna remove some noise for the edge detection, for the better visualization of edge detection. So first what I'm gonna do is I'm gonna apply some bilateral filter on it. So B filter, I'm gonna multiply it with some kernel multiplication. So we have discussed everything in my previous video. I'm gonna give bilateral filter, and I'm gonna pass the grayscale image, and I'm gonna multiply it with this number over here. So later that I'm gonna identify the edge image over here. So edge equal to cp2.canny. So we're gonna do a canny edge detection, and I'm gonna pass this bilateral filter, and I'm gonna pass the canny edge detection number as 30,200, which is the min and the max value. After that, what I'm gonna do is let me show this piece of image. Let's see what it's gonna show over here. So I'm gonna copy paste the same thing over here. I'm gonna pass this edge instead of showing gray. I'm gonna show the edge over here. Let me run this piece of code. Okay, now I have identified all the edges from the image. Now let me try to apply contours. So contours is basically identifying the continuous lines which is connecting the edges. So let me identify the contours now. So let me identify the key points first. Key points equal to cv2 dot find contours. So I'm not gonna use the real image, so I'm gonna do a deep copy of this image. So what I'm gonna do is edge dot copy. Okay, so I'm gonna copy this image. So for the contour identification, we need to pass mode and method. So this is the mode and method retr3, and I'm gonna pass cv2 dot chain approximation. Okay, this two is done. So what I'm going to do is this line is going to get all the contours. From the contours I need to import, I need to identify only the important contours. For that we do have a package like imutils. Let me check whether this has been, okay, I do have imutils installed, else you need to do the pip install. So I'm going to identify the important counters. So it is imutils dot grab contour. So basically it is going to return me all the contours numbers of array. So I'm going to extract only those contours from the key points. Let me show you how it looks. So I have taken the important one actually. So let me try to print this. Okay, you can see that it is nothing but a numpy of pixels over here. So yeah, let me remove this. So I'm getting important key points of contrast from here. So next what I'm going to do is like I'm going to extract the top 10 important counters. I mean the top 10 edges, because if you look at this piece of image, there is no much like continuous line. So you can see that the line is getting breaked over here, but see this rectangle and this glass is where we have the important one. So I'm going to take the top 10 counters. So what I'm going to do is like contrast equal to sorted. Sorted is a Python utility again. I'm going to sort the contrast. So when I say contrast, it is nothing but a list, or it's like a numpy of text, right? So contrast equal to sorted contrast, and I'm gonna pass it actually equal to cv2.contour area. Only extract those area, and reverse equal to true. I'm gonna reverse it in the descending order. So okay, and what I'm going to do is like I'm going to extract only the first 10 index. So that's what it does. Okay, there is some issue over here. CV2 dot I think it is contour area, CON over here. It's not contour over here. So this contours can be hexagonal, polygon, or anything of square or anything, right? Now I need something like rectangle, because all the number plate will be of a rectangle or some kind of a square shape with the four-sided. So if you look at this glass, right, this glass will be some kind of polygon, or we can say something like this. This is also some kind of hexagon or polygon, six-shaped or four-shaped images. So what I'm going to do is like I'm going to take the boxes which is of less than, which is having 10 sides. From the 10 sides, I'm going to extract those which is having 4 sides actually. So what I'm going to do is like I'm going to extract those pixels. Let me show the contrast again. Yeah, again the contrast is nothing but the connecting lines with under coordinates. It's not the some random number. The number over here is the coordinates from this pixel. So what I'm going to do is like I'm going to check this contrast. So which is having rectangular in shape. So for that I'm going to get the exact location of it. I'm not okay. So what I'm going to say for contour in contrast. So what I'm going to do is like for contour in contrast. So I'm going to do some approximation over here to check like take some 10. So I'm going to do some approximation over here. Approx poly dp contour comma 10, which is less than 10 shape, 10 size actually. So after that what I'm going to do, if length of APP equal to 4, which should be a rectangle, so I'm going to take that location. So this image is taken exactly by keeping the car number plate as a center, so it will work for this piece of image. If you have a multiple noises, then you need to look for other option. So this is kind of a easy and simpler way. So if you take the front part or the back part of the car alone, so that we can easily identify using a plain OpenCV. Okay, I'm gonna break it over here. Oh, okay, so approximate spelling mistake, APPROX. So let me print the location. This location is nothing but the location which is having the place where the number plate is exactly located. So what I'm going to do now, I'm going to extract that location alone. So how I can do that is like, let me create some dummy numpy of array, max equal to np dot zeros. This is nothing but it's going to create a numpy of array with a grade of shape of np dot uint. Okay, let me run this. Okay, so this is gray dot shape. From the gray, I'm going to take the grayscale image, the real car image, and I'm going to fill it with zeros. So basically what I'm going to do is like I'm taking this car image, the shape of this image, and I'm just filling all the thing with zeros actually. So basically it will be of a black color. Okay, so next what I'm going to do is like I'm going to create a new image. Let me write the code. New image equal to cv2 dot draw counter. So draw counter is basically going to draw the line over there from the masked image. So what I'm going to do, I'm going to pass the location and I'm going to make it as 0 255 minus 1. Let me tell you what does it mean over here. and then I'm gonna show the image. Let me show the image. Let me convert it actually. New image equal to cv2 dot bitwise, and I'm gonna show the image. While showing, I'm gonna show the image by masking actually. Mg comma image and mask equal to mask. Okay, cv2 dot draw contrast. So there is a spelling mistake over there. Contrast. It is draw contrast. It's not contrast. Okay, this is done. Now let me try to show the same image. So I'm gonna do the plt.im show. Let me copy paste the same piece of code over here, but here I'm gonna change the image around. Instead of it, what I need to do is like I need to give this new image. So let me run this code. Okay, so what I did is like as I told, I'm gonna take this full car image. I'm gonna mark everything as black. So everything will be black. Then what I'm gonna do is like from the original image, I'm gonna crop this particular location alone. So I'm gonna show that piece of location alone. So here we have identified the exact driver number plate. So now what I'm going to do is like I'm going to find this x and y coordinates. Once after finding this x and y coordinates, I'm going to crop that part alone, and after that I'm going to use some ECOCR package to extract the text from it. So I have already written the code. Let me write it actually. I mean, let me copy paste it actually. So this is the piece of code. So what I'm going to do is like from the mask, I'm getting the x mean and y mean value. I'm just cropping the image and I'm going to show that particular image alone. So we can see right from the grayscale image, I'm just cropping this coordinates alone. I'm adding some 1 over there just to avoid some the number plate is getting broken. I'm getting some extra pieces over there. So now we are using ECOCR Python package to identify a text from the image. So we have imported it and we have used the cropped image which we have cropped in the previous step, and we have fed into this package. This package is identifying the text. Once we have identified the text, we are displaying the same on top of the real image by drawing a bounding box. So basically this is the number which has been identified by our ECOCR package. Yeah, that's it with the today's video. Thanks for watching the video. If you do like the video, kindly like and subscribe the channel for the upcoming videos.